All right, let's take a look at this multiple choice review, prepping for our 9.1 to 9.6 test. So these are some examples of what the multiple choice questions will look like. In some cases, we'll have very similar questions. So the first one says, which of the following series converge? So I want to run through a quick nth term test. These are all bottom heavy, so they all have potential. This one is a P series. P is 1/2 though, so it diverges. So I'm going to cross out any answers that have 1 in them. This next one, actually, let me skip to 3 because this is geometric, and E is 2 point something, pi is 3.14. So this is geometric and it converges. So none is out, 2 only is out. And then back here, I need to do like a ratio test on this one. So I'm going to try to squeeze it in here. You'll have more room to work on your test. More space to do this stuff. But I'm doing ratio test, the n plus 1 term divided by the n term. 3 to the n cancels with 3 to the n plus 1 and leaves you with 3 to the first. N factorial cancels with n plus 1 factorial and leaves you with just n plus 1 because it's n plus 1 times n factorial. And this limit of 3 over n plus 1 is 0. So this one converges by ratio test. All right, so it's got to be 2 and 3 only. Which of the following converge to 2? All right, so the only 2 types of series we can do to get sums are geo and telescoping. Now, the terms to the first term are approaching 2, but this diverges by nth term test. If it said which sequence converges to 2, then this sequence converges to 2. The terms are approaching 2, but the sum is not 2. This will diverge. So nothing including 1 can be an answer. Now, these next 2 are geometric. So remember, with a geometric series, you need to look at, and if it helps you to rewrite it, you can. This is, do this up here. You don't have to rewrite it, but the -8 is out here. The fact that this -3 is in the denominator means you could have a -1/3 to the n. All right, so A1 in this case is -8 times -1/3. So it's +8/3. And R is -1/3. And the formula for this is the A term divided by 1 minus negative, so plus R. That's 8/3 over 4/3. So that answers 2. Okay, so 2 works. So it can't be 3 only. All right, and then this one is also geometric. This is 1/2 to the n. So this time you want A0 because this starts at 0. So A0 equals 1 and R equals 1/2. So this would be 1 over 1 minus 1/2. 1 over 1/2 is 2. So both 2 and 3 work, which is my answer again. All right, which of the following series converge? So this one is going to be a ratio test. I'm guessing it converges because it's a lot like number 2. The only difference is it's got a higher base number. So I'm sure this converges, but let's just pretend we didn't already do that first one. So I would do nth term test. And the 8 to the n cancels with the 8 to the n plus 1. You're left with 8 to the first. Because n plus 1 factorial is n plus 1 times n factorial, this n factorial will cancel with the 1 down here, but you'll just be left with the n plus 1. So same thing as on this first question. I do get a ratio of 0, which is less than 1. So this converges by ratio test. So 1's in the running. That means 2 only and 3 only are out. What about n factorial over n to the 100th? This is nth term test. This diverges by nth term test. Although, again, if you're not sure, because n to the 100th is pretty extreme, you could do ratio test again on this. But the power doesn't matter. The factorial will outrun it. If this were like, If this were more complicated than n to the 100, if it were 5n to the 100 or, I don't know, e to the n to the 100, maybe I would compare, because then the factorial, plain n factorial, might not grow faster. Then I would do ratio test. What's this one? This is n plus 1 over n cubed, essentially. So it is bottom heavy. Does this converge or not? I guess I would compare this. So this is like n cubed plus some other terms. I don't even really care what the other terms are, because I can do a comparison test with this. So I can say, let's compare n plus 1 to n cubed plus whatever else. Compare that to just n over n cubed. These other terms will be addition, so this fraction will be less than this one, which is 1 over n squared. And I know that this series, I'm doing things very informally because this is just multiple choice, right? So this series converges, and it's the series on top. If you're not sure if it's the series on top, then you could do limit comparison test too, but this does converge, and that makes the series below it converge as well. So 3 works and 1 works. So 1 and 3 only are my choices. All right, which of the following series diverge? So that could be nth term test, p series, whatever. Let's look at this one. Sine of 2 over pi. Now, sine of 2 is like 2 radians. I know we don't know that exact value, but here's 0 radians. And let's see, here's 1.57 radians. Here's 3.14 radians. So what's the sine of like 2 radians? What's the y value there? I don't know. It's something less than 1. I know that. That y coordinate is less than 1. It's definitely less than 3.14. So this is a ratio where r is less than 1. So this converges by geometric series test. That's pretty tricky. You could verify sine of 2 radians. It just needs to be smaller than 3.14, blah, blah, blah. This next one is a divergent p series. So which ones diverge? I'm going to cut out any ones that include 1, because I know that's not true. And 2 is in the running, so it can't be 3 only. So actually it has to be D. If I'm worried about time, I'm going to leave it here. This one does diverge, though, because of nth term test. So the limit as n approaches infinity of e to the n over e to the n, the plus 1 is insignificant in the long run. That's equal to 1. All right, let's look at the next one. Which of the following statements about this series is true? So before I'm even looking at the statements, I'm noticing, this is an alternating series. I'm just going to run the alternating series test real quick because it's so quick to do. The limit of the terms are going to 0, and I'm assuming they're decreasing. So the series can be shown to diverge. No, it's converging by AST. Diverge, nope, converging. Converge by comparison to this. So I didn't use a comparison test. Shown to converge by the alternating series test. So there it is. Could it be shown to converge with this one? Possibly. But I know for sure that this is true. So, yeah. So I'm not going to bother doing maybe I would come back to that, I guess. If I had time, I might come back and try comparison. Oh, when it says comparison, by the way, notice they say comparison versus limit comparison. This does mean direct comparison. So maybe that's the hang up. Maybe direct comparison test doesn't work in that case or something. I don't know. All right, let's see. If a sequence is cosine of pi over n for n equals 1, 2, etc., which of the following statements about the series from 0 to infinity must be true? The series from 0 to infinity. Let's see. So if we have cosine of pi over whatever, remember cosine will always fit between -1 and 1. And if that's the only thing happening here, then yeah, the nth term test is going to say the limit as n approaches infinity of these terms. you're always going to be, in the end, either adding 1 or subtracting 1. So that's got to diverge because that limit is not equal to 0. So that's nth term test, right? All right. Which of the following series diverge again? Same thing we just talked about. This limit is equal to plus or minus 1. So by nth term test. So this limit as n approaches infinity of, I'm just going to say a sub n there, is equal to plus or minus 1. So does that diverge? Yes, 1 diverges. So these two options are out. What about this one? This looks compound interest-y, right? Although actually it's not compound interest-y. There's no like exponent up here. So what would this limit be? Well, this limit would just be 1 plus 0. So yeah, that's diverging by nth term test. So 1 and 2. So 1 and 2. Okay, so that doesn't narrow anything down. And then this one, kind of the same thing. This limit, if you're putting n right here and 1 over n squared, the second term goes to 0, but the first one will be like infinity plus 0. So all 3 of these diverge. Which of the following series converge? All right. Now, absolute value of sine means that the most this can ever be is 1. Sine and cosine, they can be anything between -1 and 1. So I can compare sine of n over n squared to 1 over n squared, and it'll always be less than or equal to that value. And I know that this little p series converges. So that means that it's pushing down on the other one. So 1 does converge. So that knocks out 2 only and 3 only. This is 1 over e to the n. So this is the same as having 1 over e to the n. So that converges by geometric series. So now it's not 1 only. And it's not 1 and 3 only. So it's got to be 1 and 2. For number 3, if we could do either a ratio test, I think, or a comparison test, and we should get that one diverges, right? Yeah, because we'd be comparing it to 1 over n, and that diverges. So, okay. Which of the following series are conditionally convergent? Remember, that means that the alternating converges, but the positive diverges. All right, so first just do a quick check. Do all of these converge? Alternating, terms approaching 0, yes, yes, yes. Basically, if it's alternating and bottom heavy, it converges by AST. So now we're just looking at the positive version. So just knock off the -1 part. 1 over n diverges, so that's conditionally. 1 over n cubed converges, so nope, that one's absolute. And the third one, the p series, diverges. So it should be 1 and 3. This series converges to S, some actual sum. Based on the alternating series error bound, what is the least number of terms the series of the series that can be used to sum the partial sum that is within 0.03? Yeah, that's a weird number of S. All right, so this would be a calculator allowed problem. I'm still going to set it up though. So they're saying we have some sort of partial sum that's equal to some sort of remainder. And our alternating series error bound just means we know that this error is always less than or equal to the n plus 1 term. And we're trying to keep that less than 0.03. So what would the n plus 1 term be? Ignore, because it's an absolute value, ignore the negative part. It's just 1 over square root of n plus 1. Needs to be less than 3 over 100. You're allowed to flip this around, remember. 100 over 3 needs to be less than square root of n plus 1. And you can put either one of these into your calculator. So let me show you 2 ways to look at this. So I could do, it's probably easier to do this version. This would be a lot more straightforward. Go ahead and put in the square root of x plus 1. And down here, put in, or no, don't put anything in down here. Sorry. I'm in solving mode. Now, make note of your answers. They range from 34 to 9,999. We're looking for the least number. So start here. How do I quickly get to this value in the table? I can go to second window and type in 34 and then second graph. This is not it. I need 100 over 3, which is 33 and a third repeating, right? So that's not it. Skip to 333. That's not it. Skip to 1,111. Okay. And skip to 9,999. Oh, wait. Now I'm missing something here because I don't have 100 over 3. What's happening? Oh, 1 over. Whoops. No, wait. I didn't have 1 over. What's happening? let me do this the other way. I'm missing something. It's too early in the morning. All right, sorry. Let me do the fraction version. This plus this is supposed to be less than 0.03. Let's go back to our table. So if I plug in 34, I'm definitely not getting 0.03. If I plug in, what's the next one? 333. Closer, but not quite. If I plug in 1, 1, 1, 1, 1. Oh, there it is. Oh, and it says 0.03 here, but I always go to it. This is less than 0.03 because we're not rounding. So that is the smallest number. Even though more terms will obviously work, will be more accurate, the 1,111 is the minimum. Now, why wasn't that working the other way? Let me see. What was I doing? The square root of x plus 1. So 100 over 3 is 33 and a third. Okay. And the square root of x plus 1. Oh, weird. Okay. I don't know what, I must have mistyped something, but yeah, this is bigger than 33 and a third. So that would have worked as well. I don't know how I had it typed in before. Sorry, you probably know, but I couldn't see it. Okay, so you have both options there. You definitely have a calculator for those. You could also just plug into your home screen. Plug in what is square root of 34 plus 1, square root of 333 plus 1, and you're just checking to see if it comes out. If this series is approximated by a partial sum with 15 terms, what is the alternating series bound? So they're saying, let's look at this. Remember, the error of 15 terms is less than or equal to the 16th term. So all we have to do is plug in 16 into the series, and it's an absolute value. So 1 over 2 times 16 plus 1. 1 over 2 times 16 plus 1. As a fraction, 1 over 33. All right, next one. Oh, last couple here. If this series is approximated by this partial sum, so we're just going like I did before, from 1 to k, what is the least value for k that gives us an alternating bound of this? So again, this would be calculator. So all they're saying is, remember, this error bound is less than or equal to the n plus 1 term. And we want to keep that under 9 over 10,000. So we're going to plug n plus 1 into this expression here, 1 over n plus 1 squared. And we want that to be less than, I guess I don't need a calculator for that. 9 divided by 10,000 is what, 1, 2, 3 of these in place? I think so. So I guess I better double check that with my poor math skills so far this morning. Yes. All right. Now, Again, you can multiply this out, or I think I'm just going to, I don't know why I prefer to do it with the fraction, but maybe because I had a typo in my last part. But again, I just want to jump around here. So I'm going to go to the second window, 31, start with the lowest value and see if this is working. So we said we need 0.0009, and this is 0.00097, so that's not going to work. 32, still higher. 33, now we're under 0.0009, so it's got to be 33. All right. Last one. Which of the following statements is true about this series? This series is alternating. Its limit as n approaches infinity of 1 over cube root of n is 0. So it converges by AST. These questions are asking about conditionally or absolutely. So the non-alternating version is just a p series, and p is 1/3, which is less than or equal to 1. So the non-alternating diverges. That means that the series converges, but conditionally. It doesn't converge absolutely. It doesn't diverge. And this is not a thing. Converges neither conditionally nor absolutely. Not a thing. All right. Like I said, this test that we have, some of these questions will look familiar. Maybe numbers will be a little different. Not every question on this review is the exact question on the test, but this is a very good prep for the kind of stuff you're going to have to do. Looking at several series, deciding which ones converge or diverge, calculating number of terms to get a certain error, or finding error itself. We have 3 calculator problems, 12 non-calculator.